Bonjour, this is Professor Ken reporting to you from Haiti. How are you, statistics class? Today I'm going to show you how to estimate the probability of a sample mean if we know the population mean and population standard deviation. This is going to be on Thursday's quiz. So let me start by sharing my screen. And I'm going to turn off the video so that my good looks don't distract you. All right, here we go. So our problem, it disappeared. Oh my goodness gracious. Hang on. I can't believe that happened. I hope I didn't lose my material, but I think I did. Go to my whiteboard. Oh, here it is, thank goodness. Okay, so the mean thumb length for men is 1.23 inches with a standard deviation of 0.15 inches. That's for the entire population. What's the probability that 9 men will have a mean thumb length between 1.1 and 1.3 inches? All right, so we're going to follow this step-by-step procedure. All right, so first of all, identify the population mean and population standard deviation. So the population mean is equal to 1.23 inches. The population standard deviation is equal to 0.15 inches. And the other part is calculate the sample standard deviation. So since we have a sample size of 9 men, we want to find the standard deviation for 9, which would be equal to 0.15 divided by the square root of 9. And that's 9. And that's equal to 0.05. All right, now let's draw the graph. Push this up a little bit. There's Z. There's X. So this would be 0, and our mean is 1.23. And we want to know what's the probability that 9 men will have a mean that falls between 1.1 and 1.3. So we'll draw the partitions corresponding to those X values. There we go. All right. Now we need to determine our critical Z values. Right. And we're going to have to use the formula that Z is equal to X minus the mean divided by the standard deviation. This would be the standard deviation of 9. So for 1.1 is going to be 1.1 minus 1.23 divided by 0.05. All right, let's go to our decimals. So 1.1 minus 1.23 is negative 0.13. So we have negative 0.13 divided by 0.05 is equal to negative 2.6. So that Z value is negative 2.6. All right, now let's do our other one is going to be, I should put Z equals. So for the other one, Z is going to equal 1.3 minus 1.23 divided by 0.05. So 1.3 minus 1.23 is 0.07. So we can go to our decimals, and we have 0.07 divided by 0.05. That's 1.4. That's interesting. The 1.3 gives us a Z value of 1.4. All right, so now we need to find, let's start with 1.4. We need to find the area to the left of 1.4. So I'm going to go to my Google and I'm going to Google. I should bookmark it by now. Z distribution table. Like this one. Let's visit it. Okay, so I'm trying to find the area for 1.40. Okay, so here's 1.40. It's 0.9192. So this way we have 0.9192. And now we got to find the area of negative 2.6. So negative 2.012345 is 0.0197. So this is 0.0197. Now we're trying to find this area right here. So that will be equal to 0.9192 minus 0.0197. Subtracting that 12 minus 7 is 5. 10 minus 9 is 1. 10 minus 1 is 9. 8 minus 0 is 8. So our final answer is 89.15%. So let's go back and interpret this. What is the probability that 9 men will have a mean thumb length between 1.1 and 1.3 inches? And the answer to that is 89.15%, which looks very reasonable because the standard deviation is very small, and we want our mean. The range of our mean is very close to the mean of the population, so it makes perfect sense. Okay, let me stop that share. So now I hope. Why am I so dark? Well, there I am. Okay, I hope that you have a better understanding of how to calculate the probability of a sample mean. Au revoir from Haiti.